Salam, fellow AI thinkers. I'm Mohamad Al Solh, solution architect in Tahaluf Emarat Technical Solutions. We provide turnkey digital solutions for multiple industries empowered by AI and IoT. And we also work with sensitive industries like government and healthcare. What we're going to talk about today is to use the RAG technique, retrieval augmented generation, to retrieve data from a structured SQL-based database, because you usually hear about vector databases and documents, but now it's a structured database. And with the local LLM, Deepseek R1, the 7 billion model. So what does that all mean? What problem we're trying to solve? Why does it matter? Now, I'm going to give 3 points. First of all, most enterprise organizations, they store their data in structured databases, in relational databases, SQL-based databases. So I want to enable end users to retrieve the data in a natural text way, just in a chat conversation way, in a natural language way. And second thing is, why am I using low-code AI agent builder or LLM orchestration? Because me as a solution architect, I also am a geek, part-time geek, full-time solution architect. So what I'm trying to do, I have some very limited time. So I have some designs in mind. I want to bring these designs to life. And I want to modify them iteratively. So that's why I'm using Flowise for that. Third thing, why am I using a local LLM? Why not the public APIs? Being a part-time geek, I'd like to also blend the hobbies with the on-work experience, that it can be something useful. So usually we cannot sacrifice anything related to data privacy, compliance. So that's why it's better to control our own availability, our own privacy, and use the local LLM for that. I'm going to ask a question. Have any of you used Node-RED before, for example? Node-RED. Okay, so it's like a low-code IoT platform, event-driven low-code IoT platform where you put nodes and connect IoT devices together. So Flowise is akin to Node-RED, but for AI and AI agents. It's the same thing. Another thing, just for the concepts, have you taken a look before at ThoughtWorks Technology Radar? They keep on providing what are the latest trends in technologies, tools, techniques. So they keep on releasing their what are the tools, techniques to adopt or to try or to hold every half a year. So it's amazingly the RAG technique, retrieval augmented generation. It has been gaining traction, and it is in a record time has been moved to adopt stage. Adopt means it's safe to use it even in production. It's highly recommended to utilize this technique. We talked about the problem. We talked about the solution approach. What are the concepts we're trying to use? So I know you're aware about RAG, but I would like to also position why RAG. There are multiple techniques to utilize LLMs. With simple prompt engineering, you can retrieve your data, but there are some limitations. The very famous word, hallucinations are always there, right? So, and also if you have some private data you would like to bring in, or you'd like to query, so you need to use an external database. You cannot rely on the large language model, which is publicly available, trained on internet data, to retrieve your own data, all right? So that's why retrieval augmented generation came into picture, so that it can give you a technique where you can retrieve the data by generating, instead of the answer, generating the way how to query the answer. Well, we get back to that. Why retrieval augmented generation, not something else? Like, for example, fine-tuning. Fine-tuning, there are techniques which is more now efficient now, but by fine-tuning, you will have to keep on training the model, fine-tuning the model with your specific data. Let's say like FAQs, frequently asked questions. So if you have something new, you have to keep on training the frequently asked questions to that model to fine-tune it. But if you want to keep your data up to date, with retrieval augmented generation, you can even retrieve the data that has been stored 1 minute ago or 1 second ago, or even in milliseconds. Of course, nobody will go for a fully fledged trained model. They need huge data centers, and only few companies have access to that, right? Now, I want to give you an idea about the table structure that I'm going to query. It's a sample database with multiple companies and their IPO year when they went IPO, and what was the sale value, and what was the market cap, and bunch of other information about companies. So that is stored in an SQL-based database, which is locally hosted. So I can switch to just to elaborate what are the components hosted in here. So I have a single store database, single store DB, which is MySQL-based database. It's a MySQL flavor database. And I have the Flowise low-code LLM orchestrator, also running as a container. So let's talk about the architecture. So for describing the architecture, usually I like the C4 model, which is the most ideal one to explain. First, you explain on a high level, then you zoom in. So from the system context point of view, I have the person who's asking a query, chat, and the query is being processed by the LLM orchestrator. And the LLM orchestrator is interacting with the database and with the Olama locally hosted LLM models running on top of Olama. You're all aware about Olama and how accessible it helps to run the models locally. So Olama is running, you noticed Olama is not running as a container, it's running directly on the laptop. It's better for me for controlling the connection to the GPU too. So if I want to dig one more level down, so inside Flowise, there is a chat web UI, which is based on React.js. And there is the RAG flow, which is running inside. It runs as a sequence. First, it tries to extract what is the schema of the database, the structured database, and tries to understand how does the company table looks like, what are the attributes, what are the data types, right? And after that, in this node here, within the flow, the responsibility of it is to generate the SQL statement. Like from the SQL schema that has been extracted, I have a prompt where I give it a few samples and I give it the instruction, what do I want to generate? It's a few short prompts technique. And it generates what is the SQL query that I want to fire to the database. All right. Next, there is like a condition node where it tries to check, is this query valid or not? And then after that, it will run another node for trying to execute the query into the database. Yeah, go ahead.
So the node that checks the correctness of the SQL query, does it do just syntax check, or does it check also whether the query is correct, but it references a table that don't exist?
Good question. Syntax for now, but if you think about the future, perhaps you can add another agent which actually checks the correctness of the query itself. So if the query is valid, it will move on to the next node. If it's not valid, there is a simple Llama 3.2 3 billion model, which just generates the error prompt, a user-friendly error prompt. And I don't need to use the advanced Deepseek model for that. I just can use a smaller model for that. And then if the SQL is valid, then it will return the results in JSON format. How is that? I take that SQL, I fire it into the MySQL database, and I try to get the response, the list of records, and return it in JSON format. And after that, I generate, I pass it to another node where it's another, let's say, I don't like the buzzword. You can consider these as two AI agents. This has a limited scope to generate the SQL, and this has a limited scope to make the response user-friendly and as much detailed as possible. And this node also, it runs the Deepseek R1 7 billion model. All right. So this is the overall flow. And we can now move to the demo itself on Flowise. A small story to begin with first. I started to wonder, can I do this RAG flow locally? So earlier, before Deepseek have been released, there were some small models like Llama, Phi, and others. And they were not quite performant to do this kind of job. It requires a higher level of complexity to generate the SQL statement based on the schema. And I was using OpenAI before that. I was directly just using the OpenAI APIs. So I was thinking, okay, can I replace OpenAI with a completely local flow that is off the grid? So I tried to experiment, and I found some model called SQL Coder, but that's quite narrow. It's just for Postgres databases, and the prompt engineering is very limited in it. So what I did after that is I replaced the OpenAI nodes with the Deepseek nodes, which are running locally on the laptop. You can see this host is actually the Docker internal host so that it can reach to the machine IP. Okay, so it's running the Deepseek R1 7 billion model in here instead of the OpenAI model through the API earlier, right? So what I had to do overall, I had to just replace this, and I did some few tweaks, which I'll discuss next. Let's go through the flow. So the beauty of utilizing similar kind of low-code platforms like the Flowise, and which are specialized for AI orchestration, AI LLM orchestration, and AI agents, is that when you saw the architecture, the diagram, the diagram itself, it's very similar to what you see in here in the flow that you're trying to build for the LLM model that you're trying to execute. From a glimpse on this flow, I don't really need to go and dig deep on what each line of code is trying to do. Just from one look at the design in here, the design reflects the application itself. Design reflects what is expected to happen in here. So at the very first stage, we said that there is a function which is trying to execute on the SQL database, trying to extract what is the schema, right? So I know what you're thinking right now. You promised me with low code, but this is code, right? And just as a small, so just as if I tried to show you that there is no low code or no code, but actually it is. There is some code in the engine behind it. So why am I writing code? Because using Flowise, there are out-of-the-box nodes which does some specific functions, but if I need to do something specialized, like extracting the schema from a database, this is not private, don't worry, my secret password, anything, it's just a default database connection string. Yeah, so it's trying to query the master tables to see where is the table and try to extract the schema definitions, okay? So, and even if it's code, it can be generated with generative AI even. So I tried to even optimize some of the code with generative AI itself. So next, in the prompt template, I'm doing a few shots prompt technique where I explain to it that, okay, you're a MySQL expert, create a syntactically correct MySQL query with adding a limit of 7 rows when you try to provide the answer. And here is the schema from the previous node. And here are some examples to understand what I'm trying to reach. And after that, here is the actual question that I'm trying to ask from the end user. I want you to generate the SQL query, okay? So after that, it will go to the LLM chain node, try to take what is the, try to apply what is the LLM model to run on it from Ulama, and what is the prompt that I'm trying to pass. And the output, I will take the output, and I will clean the output. You will notice this is one of the first things I tried to change when I changed from the OpenAI API to the Deepseek R1 model. I had to remove the thinking tag, right, using regex. So that's one of the techniques that had to be done. Another technique that had to be done is to try to extract the SQL query itself. So trying to extract the SQL query, when I was using the OpenAI APIs, it was quite a bit consistent. And I don't have to also try to look where is the SQL tag, where is the SQL statement. It wasn't trying to produce different behaviors every time. Sometimes it surrounds it with code surrounding statements. Sometimes it doesn't. But unfortunately, this happens with Deepseek. So in the prompt engineering technique, in the previous step, I tell it, please surround the SQL statement with X and Y, okay? And then after that, when I try to extract the SQL statement, I tell it from the regex that this is how I want you to extract the SQL statement. It's surrounded by these tags, right? After it is extracted, then there is a simple, as you asked me, it's just a simple syntax check to check if it's syntactically correct, the SQL statement. But it can be replaced with an AI agent later on. All right, so after that, what happens is it will run a custom function to retrieve the data from the database, and another prompt to try to formulate the data in a user-friendly way and explain it as much detailed as possible and show it back in a tabular format. Here I had to also do some optimization, which I will explain while running the demo. So let's run the demo, since the time is a little bit limited here. So while running from Flowise, you have multiple options. You can either embed a chat box inside your own website, or you can directly run the chat itself from here, or you can have the curl command and call it through an API to get the answer. So I'll run the chat itself. You can see I had a lot of tests earlier. So I'll run the first test. What are the companies that went IPO in 2017? Sort them descending by the last sale. So what is happening in the background? I'm having a log file opened in here just to check even the container, what's coming out of it as a log. Let's see it side by side here, what's happening. So it's still thinking, trying to extract the SQL schema, trying to generate the SQL statement. And it generated the SQL statement. You can see the SQL statement generated in here, right? So I'll take this SQL statement, and I'll run it in dbeaver. So this is the SQL statement. Let me run it. So I'm expecting to see these results in the chat box, right? The first one, major pharmaceuticals. The last sale is the highest sale, 122. So this is the bit of a downside. Like, you have to wait for the thinking tag to complete. But I kept it. I didn't try to remove it while trying to generate the chat. So it generated it correctly. The last sale is the highest sale, which is 122, which is correct in there. Another test. Let's paste the second test. The second test is important. There's one important point I want to highlight on. The market cap. Now, the market cap, the question is, what are the companies that went IPO in 2017 in the technology sector, and sort them descending by market cap. So let me hold on. Sorry, sometimes it happens, you know. I was trying to, as much as possible, to optimize the prompt engineering so that doesn't produce any errors, but it could happen. It can happen sometimes. So I'll wait for the SQL statement to execute. The idea is the market cap is written as a string. It's not a number. So if you're using a database engine and trying to run the query and trying to sort descending, it will not try to sort the billion before the million, right? So here is the SQL statement. Let's take that SQL statement for the second query. And paste it here. All right. So you can see it showed first 700 million, which is the highest. Actually, the sorting is not correct in here. It's 700 million, and then 66 million, and 575 million, and then the billion at the bottom, which is not correct. But if you check what is happening in here, it's trying to think, and it's trying to actually sort the records correctly. I hope it works this time, because it's still, because the model is quite small, 7 billion. So it's not as much accurate as the higher models, the larger models. But executing these models locally, it's very feasible, and you can execute up to 32 billion using a 3090 GPU, even if you connect it externally with a Thunderbolt cable. So you can see what it did. It converted first to millions, all the records, to have a consistent value, and then sorted them descending in the correct order, which is even a better behavior than trying to execute it in the SQL statement alone. So key takeaways we want to get out of this. So first of all, democratization of AI models, the open source models that are being released and being enhanced. They are quite an enabler for multiple regions, multiple organizations. They can all run on their own availability, on their own privacy, and it is accessible to all. Second takeaway is using the low-code technique. It helps non-tech savvy users to try to build their application with not a lot of code, but it also helps them. There is a saying that the low-code platforms or low-code techniques are like the prompt engine for non-tech savvy users to build applications, right? So, but for the tech-savvy users, like developers, coders, like all of us, thinkers, it also helps you to rapidly develop your application that you need. It helps you to bring your design to life as quick as possible and try to think in an iterative way. Okay, I build it first in this way, and then I want to enhance it, I want to change it. I can change it easily, all right? So these two main takeaways I want to come out with, but also one more small information in the future, what I'm planning to do. In this platform, there's a marketplace, and there are so many out-of-the-box LLM flows that I want to experiment with, and it's a big playground. Actually, there's one of them is quite interesting. It's a prompt engineering team. So a prompt engineering team is a flow which helps you to generate the prompt engineering statement by a flow. So it's like, if I compare, if I just show you this one, it's like, you know, you're like, I heard you like AI agents, so I used AI agents to create AI agents. Why do you use AI agents? So it's just like using the AI agents to create the prompt engineering techniques to create AI agents. So this is all, and this is my LinkedIn profile. If you'd like to follow me, there is a small caveat. I promise that I will not do any pitches, but actually we have a webinar on low-code platforms, and it's featuring a Forrester analyst expert who is going to talk with us about the trends, the use cases, the critical functionalities, and the challenges, and even including trends of what's the impact of these new generative AI models, the local ones, on the local platforms in general. But it's more into like the enterprise local platforms for creating applications. So if you'd like to follow me, and I'll also share you the post of the webinar if you'd like to register and join. We'll further talk about that. And this is the QR code for the GitHub. If you're interested to see the code, the JSON flow, you can import it to Flowise, and you can start to experiment with it.
Wait.
Oh, sorry.
They're still scanning. They're slow to scan.
Yeah, sure.
Yeah, okay.
So
at that point, we keep it over here.
Any questions?
We take questions.
Yes.
Yeah, what are your impressions of Deepseek? Is 7B enough or not? What are your impressions of Deepseek? Yeah, because it's small model, 7B.
Yes, what's the opinions? 7B, I've just tried it on this kind of scenario to generate SQL statements to do some simple coding, which is fine. But to try to summarize documents, I'm trying to run the 32 billion, and it's quite well, actually. So I'm also trying to explore the multimodal models, even the ones from Hugging Face, like QuenVL, to try to see what are the possibilities that we can do, like even to try to do some kind of intelligent document processing using those small LLM models, the vision-based models. So my impression overall, it's quite as performant. I've even tried to do one practice. I ran the 32 billion side by side with ChatGPT. I tried to ask the same question for some difficult problems. And I'm seeing consistency. I see, for example, Deepseek is answering as good as ChatGPT, the 32 billion. It missed it only in a couple of points out of 10. That's the overall impression that I got till now. Thank you. Any other questions?
You mentioned for the flows. There is one node for validating the generated SQL code. Then in this node itself, it can optimize the SQL code as well.
That's the same question that was asked earlier. It's actually doing it only through regex check, but it can be done as an agent by itself. We can create one more agent and give it the limited scope responsibility to just try to check that SQL syntax for correctness, which is something that can be done in the future also. Any other questions?
Have you tried this system with multiple tables because it generates proper joins as well?
Good question. To be frank, this demo was only for one table for now, company table, but it's a good future work that can be considered for later on.
Yeah, because I was thinking that usually RAG systems use chunking a lot, and since it wasn't done here, then like maybe it can't handle larger and more complex records, or maybe records from multiple tables.
It can be, but we can do the two models. If we're doing chunking, we're trying to do some kind of a data management solution to take that SQL database and try to chunk it and its output, its text, or its tables, the whole DML inside, try to chunk it and put it in a vector database. That's another technique, but you will still have to update that vector database, and there will be a slight delay. You have to run that job perhaps like every hour or every day. It's another technique, it's possible, but it will not maintain the same recency of data. If you directly depend on the SQL statement to be fired on the database, you will get the most recent data available in the transactional database. And I was thinking like, okay, if I'm hitting the transactional database, I might put on some load, right? So I can have also a read-only replica and just hit the read-only replica to reduce the load. Any other questions? All right. Thank you for your attention. Thank you very much.